Hello, everybody. Welcome to the talk. I first want to thank all the organizers and the volunteers who can make this happen. It's really great to be here. Also, thanks for you guys for skipping Vlad's talk to be here. So, I'm from LivePeer, and I'm one of the core devs. And LivePeer is a decentralized video live streaming network that's peer-to-peer. So what that means is instead of using a centralized video service provider that provides video streaming services, in LivePeer, people stream video from and to each other in a peer-to-peer manner. And before I get started, I'm going to start broadcasting to my mom, who lives in Japan, because I told her that I would do this. And now I just have my phone here to show you guys a little bit of how this works. So right now, what's happening is this is all running on the Rinkeby testnet. It's streaming from my phone into a peer-to-peer network, and it's using the incentives in the peer-to-peer network to stream the video around and to do the processing of the video. It's also using some protocol level verification to make sure the computation can happen in a trustless way. So today I'm gonna, you can see there's a little bit delay, and in regular internet broadcasting there's about 30 seconds to a minute of delay. So today I'm gonna talk to you a little bit about how this works. I'm not gonna go into all the details because there's not enough time, but I will talk about some of the decisions that we've made in order for this network to work with Ethereum as it is today. To overcome some of the challenging problems for scaling on the network, and then tell you a little bit about the future of the network and what it holds. So let me go back to my slides. Cool. So to understand how video works inside LivePeer, we first have to take a step back and talk about how video works today in the centralized web, right? So, when I'm pressing stream from my phone, it's not just going. The picture is not just going directly from my phone onto some device, right? There's this kind of treacherous process that the video has to go through in order to reach all kinds of devices in kind of all over the world. So, so just a quick walkthrough. When you broadcast a video from any video source, usually it gets inputted into a cloud-hosted media server. This media server does a few things that are really important. One is that it transcodes all the video into all kinds of different bit rates and all kinds of different formats in order to be able to serve it in any network condition. Right? Think about like your phone being on a 3G network versus sitting at your home. Maybe you have high-speed internet. That's a very, very different requirement. Also, all kinds of devices with all kinds of, a video on the phone is a lot smaller than a video on HDTV. Right? So in order for the video to be consumed by all devices, there's a lot of processing that's involved. Another thing that it can do is to store the video for a later playback. And also, it can potentially apply DRM on top of the video to preserve the privacy of the video itself. And if you want to send the video to a lot of people, you have to send it into a content delivery network, which multiplies the video and then sends it to the edge of the network where all the devices are to consume them. So on top of this complexity, we also have this issue of capacity planning, right? It's kind of like building roads. When a city builds roads, even though most of the time the roads are empty, but they have to build these wide highways in order to account for when peak traffic happens, which often happens like this, right? So what you end up having is you have to build a lot of infrastructure and hold it in place just to account for when a lot of people are coming into your service and using your streaming service. Even though like AWS and Spot instances are making it a little better, because you can, on the application level, you can spin up and down these nodes. But on the infrastructure level, a lot of times you still have to keep the headroom in order to account for the capacity. And this is a really systemic problem in the video industry, right? Because this introduced a lot of cost in the industry. So if you want to do video transcoding, and you want to use a SaaS service, it costs about $3 per stream per hour. Or you can license proprietary softwares if you want to build your own stack, but also that's very expensive. Because there's no good open source solutions, no open source media servers out there, people don't have a lot of options. On top of that, the delivery of the video is also very expensive. It comes out to be about $1 per user per month for a popular service like Twitch or YouTube. And when you add that up, if you have millions of users, you could be spending millions of dollars just to deliver the video, right? And this is a big problem because this prevents existing video applications and video services to be independent entities, right? Because if you look at all these popular services on the internet that serve video, a lot of times they eventually get bought up by these giant corporations with big pockets, right? YouTube for Google, Twitch for Amazon, so on and so forth. And there's a reason behind that. That's because it's simply too expensive to run these services as an individual entity, and the investors eventually get tired of funding these projects that they don't know how to make their money back. So being able to cut down the cost is very crucial in this industry. And that's why people have been trying to do this peer-to-peer video streaming for a long time now, right? This is not a new idea. People have been trying to do this for the past 10, 15 years. And the idea here is simple, right? Instead of using decentralized services to provide the video service, we all try to chip in as a decentralized network, right? Maybe we try to relay the video around. Maybe we try to do a little bit of transcoding for each other. And that seems like a good solution, right? Like BitTorrent is founded on a principle like this. But in a video network, the requirement is much higher, right? Because in a peer-to-peer solution, what inevitably happens is you have these trolls in the network, right? They are taking a lot of bandwidth. They're taking a lot of resources from the network, and they're not giving a lot back. And these protocols don't really have a way to effectively protect themselves against bad actors in the ecosystem. So even just a few bad actors can really grind the network into a halt. And so what these peer-to-peer solutions end up evolving to are these proprietary solutions where the client nodes are running proprietary software, and that's the only way they can prevent people they don't want from joining the system. They have to whitelist all the peers that are in the network, which takes away all the nice property of an open peer-to-peer network where we're all sharing resources and pushing the cost down together, right? But that's the past, because now we have this new paradigm of building peer-to-peer networks, right? We have the blockchain. And the blockchain is amazing because it gives us a way to create an incentive for people to actually provide value instead of just taking value from the network, right? So if you look at the middle of this picture and imagine this as the decentralized internet in the future, say like the big Web3 dream, right? What we want is we want these nodes to be able to do the video transcoding, the encryption, the storage, and the delivery all by themselves. and on the protocol level, incentivize these nodes to join the network and do that, and also weed out the bad actors who are trying to take advantage or cheat. So for an application developer, with this kind of end goal, all you have to think about is sending your video into the network and expect your output video to be sent to your viewers without having to worry about all that complexity. And that's what LivePeer has started to do in this decentralized video world. So I have another demo to show you guys, which is how we do this decentralized video processing. So let me see. So what I have done here is I have shared a video stream into my computer. And what this is doing is in real time transcoding my video into many different versions, right? So maybe the big version is for a laptop, or maybe even a bigger TV. The middle-sized version is for a tablet, and the small version maybe is for a phone, right? And all of this is happening in a decentralized on a decentralized network using a secure protocol, so that as a broadcaster, I can trust the video is done correctly. And this is what enables a really smooth playback experience on the internet called the adaptive bitrate streaming. And what that means is the player knows how to switch between the video format, the video bit rates, depending on its own network condition. So sometimes when you are playing like a YouTube video on your phone, maybe it starts out really blocky, but it gets crisper in a couple of seconds. It's not because your phone was freaking out at the beginning, right? It's because your phone was consuming a small, like a lower resolution video, and it found out that you have more bandwidth, so it started downloading a higher resolution. So I'm not going to go into all the details of the protocol itself, but I will talk about some of the high-level principles that we've followed when we're developing this protocol, right? I think one of the most important things when we're creating these decentralized protocols is to think about the participation. How can we get high-level participation in this protocol, right? Bitcoin is an example. There are two parties that participate. The miners participate by mining the blocks that then increase the security of the network, and then the token holders buy the token off of exchanges, or they simply hodl, or they trade. But that increases the value of the token, and because of the increase of the value, that drives more miners onto the network. It creates more security, so that incentivizes a high-quality participation. But you can do that for something like Bitcoin because you're simply just doing calculating the hashes, right? But for something like video streaming, it's a very special service that you're providing, because when I'm streaming this video out, I don't want anybody to be able to be just providing the service to me, right? Because if you're sitting in this room using your laptop, I don't want to be streaming my video to your laptop and your laptop is doing the processing. Maybe you close the laptop in the middle of my stream and walk away. That completely disrupts my stream. So what we want is to have participants that have the ability to provide really high-level services. Maybe these people have access to a lot of computation power. Maybe they live in a location that has very, very high bandwidth. Maybe they have experiences in keeping services running. So to do that, we have to have a different model. And what we use is a delegated proof-of-stake model. And a lot of protocols use this. There's a protocol called Steemit, which is a social network. They use delegated proof of stake to verify transactions, and in order to achieve very high throughput for social network. So how does it work inside LivePeer? Basically, any service provider, so in this case, a transcoder, can raise their hands and say, I want to be a transcoder in the network. And they can campaign, maybe they post their Ethereum address on in their social profile. Maybe they go to the LivePeer forum, and they can campaign them in a variety of different ways, right? Maybe they'll say, I know how to run a big cluster, or maybe they'll say, hey, I'm an important member of the community because I made a really kick-ass LivePeer mobile app, whatever it is. They try to get people to delegate their token toward them. And they can also provide on-chain evidence to tell people that they're credible, right? Because as a transcoder, you're gonna have history. People can know definitively how long you've been a transcoder, how much job you have done, how many times you have cheated or been slashed, and maybe your rate, which is how much you charge for the video transcoding service you provide, and also how much of the rewards that you get, you're willing to share back to the people that delegate towards you, which we'll get into a little later. So during this campaign process, token holders can pick any of these transcoders to delegate towards. And after this delegation process, what we have is at the beginning of every round, a round could be a day, a week, a month, we have this list of active transcoders that will then get distributed jobs depending on their stake in the network. So this is all good. So I'm going to talk a little bit about why this incentivizes good behavior and disincentivizes bad behavior, right? When we think about incentives, there are a couple ways to do it. One is using the fees, right? Simply letting video transcoders to get paid for the work that they do, and that's good because one, it prevents this kind of like DDoS attack where the users are spamming the network, right? Because there's some cost. And also, it kind of rewards the providers for the service that they provide. But also, okay, so in the fee scenario, the goal is to make it as easy as possible to pay the fees for the service people provide. So in this case, all the fees on the LivePeer network are paid currently in Ether because a lot of people have Ether. But I think in the future, the protocol will support any kind of token payment, right? For example, I'm really excited about stable coins. I think the DAI token from the Maker team makes a lot of sense in this case where people want to pay for some kind of commoditized utility. And on top of that, there's also rewards, right? So that gets into the territory of inflation. Inflation is an interesting mechanism because it drives a lot of adoption in the early days of a protocol, right? Bitcoin has inflation, and I'll argue that's why the Bitcoin network is able to bootstrap itself so quickly. And in the LivePeer network, there's also an inflation, and the inflation is distributed to the service providers for the special role that they take. And the service providers can choose to distribute a part of that inflation or reward to the people that stake toward them. Because the people that are staking are also participating in the network by pointing out who are good service providers. And they're kind of laying down their stake for the long term and aligning with the network. Now, we're going to get into a slightly controversial topic, which is how do you define the inflation, right? There are a lot of models out there. Specifically for LivePeer, we think the inflation should be there for a reason, right? And for a network like LivePeer, the value of the network comes from the service that it provides, right? So ideally, the bigger the network is, the better service it provides, the more valuable the network becomes. And we talked about earlier, right? High-level good participation means better value for the network. So what we do here is we peg the inflation against a participation rate. So let me give you an example. So say the current inflation rate is at 8%. And maybe our target participation rate is at 25%, which means we want 25% of all the token to be bonded, to be participating in the protocol. And let's say we're currently at 23%. So what happens in the next round is the protocol automatically increases the inflation so that it incentivizes more token holders to participate, right? Because remember, all the inflationary rewards are going only to the people who are participating in the protocol. So if you're just holding the token and doing nothing, you're slowly being, your token is slowly being diluted from the inflation. So this increase of inflation incentivizes more participation, and maybe we overshoot a little bit to 26%. And in the following round, the inflation rate automatically adjusts down. So maybe some people unbond because of that reason. And let's say we settle at 25%, which is our target rate. And from that point on, the inflation rate will keep going at 10%. Right? So that's some of the reward mechanisms that we use. There's also punishment, right? Because we want to make sure bad actors in the system go away and they be punished. And there are a few different ways to punish people. One is through slashing. Another is through kind of the reputational punishment. And sometimes you can even kick people out from participating, right? So I think like token curated registries use this pretty extensively. So in terms of live peer, what we aim to do is when we are punishing somebody, we want indisputable evidence that someone is doing the bad work, right? So I think the goal here is to make it so that it's automatically decided that someone has done the wrong work, and the protocol automatically slashes them. So what we do here is we have this trustless transcoding protocol that basically when the transcoder is doing the work, for every segment that it transcodes, it's creating these cryptographically assigned claims. And when it finishes all the transcoding, it creates a Merkle root of all the claims and writes it onto the blockchain. And at that point, the blockchain pseudo-randomly picks a specific segment to challenge, and the transcoder has to provide the proof that it has transcoded correctly. And in order to provide this proof, the transcoder cannot be the one that's doing the challenged work, right? Because they can just do anything. So in this case, we use a compute oracle to do the transcoding again, who is not the transcoder itself. And if the compute oracle writes the same result back on chain, it means the transcoder has done the work correctly. And if it writes a different result, it definitely means the transcoder has done the work incorrectly, and therefore they will be automatically slashed. So this compute oracle is an interesting question, right? Like, how do we make this decentralized, and how do we make it really good? And this is an open research question, and we're really excited to be participating in the TrueBit research. We've been working with the team for a while, and recently we've made a lot of good progress on this front. If you haven't checked out TrueBit, you should definitely do that. It's a really cool project. Use some really clever compiler level trickery to narrow down the computation to a single computation step and execute that on chain, and it's able to figure out who has done the right work. I think they're looking for compiler engineers to join their team, so if you're interested, you should definitely talk to them. And so where is the project today? We've been working on it for about 1.5 years, and we are very close to launching. The network, as you've seen, it's already running on Rinkeby, and we're hoping to deploy the first version onto the mainnet in the next month. But this is just the first version of the protocol, right? There are many open, interesting research areas that we're working on. One interesting area is inflationary incentives for video distribution, because we talked a little bit about video transcoding, right? But video distribution is another really important piece for doing the online video transcoding. Right now, the delivery works in a peer-to-peer fashion in a kind of tit-for-tat way, so that while it works, it's not going to scale to thousands and thousands of nodes participating. But with the correct incentives, this network can grow in a very scalable way. We're working on some verification for non-deterministic computation. And what that means is, a lot of times in video transcoding, in video processing, especially when you're tapping into hardware acceleration, the output is inconsistent, right? It's using some floating point calculation, and the output is always a few bits off. So being able to define that constraint in the computation and still verify the computation, even though the output is not bit by bit exact, is a really interesting area. Another thing we're working on is on-chain randomness, and this is something I think will benefit a lot of people because the picking of the challenge bit is right now pseudo-random. We want to make it. We want it to come from a better randomness source. And finally, the low-cost payment mechanism is something that people are talking about a lot, right? Payment channels. The Swarm team is working on a checkbook contract, which is super interesting, and we're happy to participate in that. And there's also probabilistic micropayments, I think, that came out of the WorkIt team. So this is something that the video industry has never seen, right? An open source, completely open platform with permissionless innovation that anyone can come and build cool products. And it's really unique for the blockchain ecosystem. So what LivePeer essentially does is it brings that kind of innovation into the video industry, right? So we just talked about transcoding, but there's all kinds of processing that you can do on top of videos to make it more engaging. Imagine watermarking, right? This is not just putting a logo on the video. If you're watching a sports game, all of the metadata that's superimposed on the feed is watermarking, right? You can do image detection, image tracking, video manipulation, any kind of object rendering, and all of this can be done in the same under the same framework. Another interesting opportunity is creating the bridge from the blockchain to the real world, right? Because a lot of application developers, maybe they don't understand crypto as well, maybe they don't hold crypto, and they want to just pay in cash. There is an opportunity to build a real business on top of the LivePeer network to just do that. And finally, there are so many dApp ideas that we have, right? And this decentralized video service creates all kinds of new opportunities that was not available before. Something I'm really excited about is uncensorable journalism, right? When a war or a conflict breaks out, the first thing that gets cut off is the live video feed. But with a decentralized network, it's much harder to censor the video. You can create auto-scalable social video services because of the underlying economic principle in the blockchain. You can create pay-as-you-go video services that really creates a tool for small business owners instead of tying them to a centralized platform that charges anywhere between 30 to 80% of the transaction. And there are all kinds of interesting dApp ideas that we haven't even thought of. So to make it really easy for people, we've created LivePeer.js. Which is a newer project, but it contains all the components that's needed in order to create a dApp on top of LivePeer and Ethereum. So the video players that I just showed earlier was a completely decentralized application that's using LivePeer.js to talk to the peer-to-peer network and the blockchain. So that's all from me. Again, I'm from LivePeer. You can find us in our Gitter at gitter.im/LivePeer. And do I have time for a few questions? One question. I'll be outside after.
Can you expand a little bit on the token model? Very interesting.
Yeah. So the token is really there to incentivize high-level participation, right? So as people are staking their token, the token is not used for payment because we want payment to be as easy as possible so that people can pay with anything. The token is really there to, as you can say, as a governance mechanism, and it's meant to say I guess one use case is for it to reward people and attract service providers onto the network because anyone can provide their service, but we want people to be participating from all over the world. And the geographic element in video streaming is important. Another is it allows people to stake their token toward certain service providers to vouch for them. And basically that's a signal for the broadcasters to come in and say, I want to, because I want to use high quality video service, then I can pick the ones that have more stakes. Yeah. All right. Thank you all for being here, and I'll be outside.